So what is a limit? A limit allows us to evaluate a hypothetical output of a function at either defined or undefined points using the surrounding values. In order for a limit to exist, the limit from the left-hand side needs to be equal to the limit from the right-hand side. If both sides do not equal each other, we would say that the limit does not exist. So let's talk about some limit laws. The sum, difference, and product laws state that you can evaluate limits term by term. The quotient law says the same thing. However, the limit of the function in the denominator can't be 0, as you cannot divide by it. The constant multiple law states that you can pull constants out when evaluating the limit of a function. The power law states that you can evaluate the function within the exponent and then apply the exponent later. There are three main algebraic methods to evaluate limits. The first thing you can do is a direct substitution, or simply just plug in the value into the function. The next thing you can do is see whether or not your function is factorable in the numerator and or denominator in order to cancel out any terms. Finally, you can try to multiply by the conjugate to see if anything cancels out and simplify your expression. If you're working with trig, you can use trig identities along with your special trig limits in order to evaluate any limits. In order to determine the limit of a piecewise function, you have to take the limit from both the right-hand side and the left-hand side. If both values are equal, then the limit exists. However, if they're different, then the limit does not exist. There's a major difference between infinite limits and limits at infinity. Infinite limits refers to when there's a vertical asymptote at the point being evaluated. Limits at infinity simply ask the hypothetical output of the function as you approach infinity. A vertical asymptote is found when the denominator is equal to 0. In order to evaluate infinite limits, take the left and right-handed limits by doing a direct substitution with the next whole number. If the value is positive, that means you're going to positive infinity. If it's negative, that means you're going to negative infinity. The limits exist when both the left and right-handed limits go to positive infinity or negative infinity. For limits at infinity, if the term with the highest power in the numerator is greater than the term with the highest power in the denominator, the limit goes to infinity. If the term with the highest power in the denominator is greater than the term with the highest power in the numerator, then the limit approaches 0. If both are equal, then the limit evaluates to the highest term divided by the lowest term. Finally, let's talk about continuity. There are three conditions for a function to be continuous. First, the limit must exist at the specific point. Second, the actual value must exist at that specific point. And finally, both the limit and the actual value must be the same number. As we can see on this graph, the value of the limit is not the same as the value of the actual point at a. So therefore what we would say is that this function is not continuous at a. On the other graph, we clearly see that the limit value and the actual value are both at point A, so therefore we would say that this is continuous.